Make sure your book is open to page 459. Today we are working on Chapter 6, Lesson 4, and this is called Multiple Representations. And we've kind of alluded to this before. We can have an equation that's connected to a table that then can be graphed. So all of those three different things represent the same idea, the same relationship, and that's what we're going to be practicing today. Okay, so let's go ahead and look at this first word problem. It says a group of friends are going to the museum and each friend has to pay an admission price of $9. What equation can be used to represent this situation? So they've started a table for us and they have the number of friends. So one friend, two friends, three friends, four friends. And then we have the total cost that the number of friends would have to pay for tickets. So we're going to complete this table and then we're going to take that information and we're going to put it in a graph. But we're also going to make an equation so that we can figure out how much any combination of friends would cost to go to the museum. So complete the table first. So if you have one friend, it costs $9. So how much would two friends cost? Go ahead and answer that for me, please. That's right. That would be $18 because 9 plus 9 is 18. Each person paying $9. How much would three friends cost? Answer that for me, please. Very good. 9 plus 9 plus 9, or 3 times 9 is 27. So we've been answering these kind of questions since third grade, so this should be pretty familiar. Go ahead and answer that final one. What would four friends cost? Very good. That would be 36. So what we've just figured out that we could actually 9 plus 9 is 18, plus 9 is 27, plus 9 is 36. If you go down the y column, really we're adding 9 each time because it's 1, 2, 3, 4. But the rule is actually comparing the friends to the cost. And what we have figured out is that that is going to be a multiplication situation. Now they have told us that they want to represent number of friends by n. So really the rule is going to be 9 times whatever n would be. All right, so it says next to it we have to describe the graph, so we have to graph it first. So if this is the x quantity and this is the y quantity, because I can invite 10 friends if I want, I can invite 12 friends if I want. The rule would always be 9 times whatever number of friends. So that means that the x value is independent and the y value is dependent. So the price will change depending on how many friends I invite. So let's go ahead and graph this. So if 1 is x, so this is going to become an ordered pair, 1 comma 9. So I go to 1 and I go up to 9. It's going to be a little bit below the 10. And if I have two friends, it's going to be 18. I'm going to go ahead and pause and finish. Well, hang on. I'll go and do it. So 2, go up to, that's a little bit below the 20. Then I have 3 is 27, a little bit below the 30. And then 4 is 36. It's going to be a little bit above the 35. Okay. Now, if I had 0 friends, 0 times 9 is going to be 0, right? So actually, 0 friends would be 0 money. So no friends, no tickets. And if I were to connect all of these, describe the graph. What do we see that is the graph? That is linear, but also the fact that it goes through the origin is very important for us to make note of. So it's linear and it goes through the origin. Now we're going to write an equation to find the cost of the tickets. And it says that the variable should be n for friends, but it doesn't really give a variable for total cost. So I'm going to go ahead and say, I don't know, what do you think our variable should be? Go ahead and answer that for me. Okay, I'm going to go with t for total cost. T is going to be equal to And all we have to do here is write the rule, 9 times n. So if I had 10 friends, that would be 9 times 10, and it's going to cost me $90 to buy tickets for 10 friends. Okay, and again, if I have 0 friends, then it's going to be 0 times 9, and that would be 0. So again, we've already mentioned it, but which one of these is the independent quantity and which is it dependent? Are the number of friends dependent on the total cost, or is the total cost dependent on the number of friends? Answer that for me now, please. Okay, so the number of friends is independent. I can invite as many friends as I want. I could invite 100 friends if I wanted to. And that would be 100 times $9 is going to equal $900 to go to the museum. But so that means that the total cost is dependent on the number of people that are invited. So the dependent quantity is going to be T. Now, in reality, though, the x-axis is always the independent value, and the the y-axis is always the dependent value. Okay, so the first thing we're going to practice is representing relationships using verbal descriptions and equations. So if the words are a runner's distance in a marathon is equal to 8 miles per hour times the number of hours, then that equation is going to be distance is equal to 8 times t. And in this case, the distance is the dependent variable, and then the number of hours that you spend running, the time is going to be independent. So the more you run, the farther you're going to get. Verbal descriptions and equations can be used to describe relationships. For example, when the rate's expressed in words, it can be written as an equation with variables. Then when you write an equation, determine what variables to use to represent the different quantities. Okay, so on number 1, we have the drama club is holding a bake sale. They are charging $5 for each pie that they sell. Write an equation to find the total amount earned, T, for selling P pies. Okay, so the words are the total earned equals $5 times the number of pies sold. So T is going to represent the total earned, and P is going to represent the number of pies sold. So in this case, we always start our equation with the independent variable. So T is the money that we earned. The money we earned depends on how many pies. So if we choose to sell 2 pies, if we put out 4 pies, if we put out 10 pies, that's going to $5 a pie decide how much money we end up earning. So 5 times the number of pies. Pies are going to be the independent variable. And so the equation is going to be T is equal to 5 times P. In this next example that they've done for us, it says, in a science report, Mia finds the average adult breathes 14 times each minute when not active. Write an equation to find the total breaths, B, and they've already given us the variable, a non-active person takes in M minutes. So M is going to represent minutes. So B is the total number of breaths, M is the total number of minutes. So the total number of breaths equals 14 times the number of minutes is going to be the verbal description. So B, breath, is the dependent variable. The breaths will change depending on how many minutes we are actually observing this. 14 breaths a minute, 14 times the number of minutes. So B is equal to 14 times M. Okay, so now we're going to connect the idea of equations and tables again with graphs. And this is really, kind of the thing we've been talking about this week so far already. So this table is the same thing as this graph. So if you have time representing hours, and then you have distance in miles, so we have distance in miles. So if we spend 0 time moving, then we get 0 distance. That's represented by the point 0, 0. If we spend 1 hour moving and it's 8 miles in that 1 hour, so if I go down the 1 hour x-axis and I go up to 8 miles, this is how far we've gone. And then if I spend 2 hours moving 8 miles an hour, 2 times 8 is going to be 16. And so we're going to go to 2 and then come up here to 16. Now, so how would we write the equation for this? So the other part besides table and graph is going to be equations. So if I start out with the dependent variable, which one of these is dependent, time or distance? Which one changes based on the other? Answer that for me, please. Okay, that is true. So I'm going to actually say distance is dependent. I'm going to use m for miles. So miles is going to be equal to, what's the rule of the table? What do we do to 1 to make it an 8? Well, let's try plus 7. So is 2 plus 7 equal to 16? No, so the rule is going to be times, I'm going to use parentheses. I'm going to stop using the letter x, times 8. So 1 times 8 is 8. 2 times 8 is 16. So if we're using h as our variable for time, 8 times whatever h is going to be my equation. So if I decide I'm going to move for 10 hours, 8 times 10 is 80, and we're going to be way up over here with our point. It's just going to continue in this linear graph. Okay, so we can actually look at this next example. It says a student council is holding a car wash to raise money. They are charging $7 for each car they wash. It's asking us to write an equation and make a table to show the relationship. So using the verbal description, they've went ahead and started drawing the table. Numbers of cars washed, total amount earned. 1 car, $7. 2 cars, $14. 3 cars, $21. So without ever even graphing this, we can write the equation because we know that every single time we're multiplying by 7. It's $7 per car. So 2 cars times $7 is 14. So what is dependent, and they've actually used the letter T over here, T, how much we earn, is dependent on the number of cars we watch. And so the rule is 7 times the number of cars. So that is our equation. T is equal to the rule, which is 7 times the number of cars. In this case, the number of cars is the independent variable. And if I were to, work all day and we actually wash 100 cars, then we are going to end up multiplying the number 100 cars by 7, and we will have earned, wow, okay, we will have earned $700. All right, so in this first part of the example, we filled in a table, we wrote an equation, and now it's asking us to graph the ordered pairs, analyze the graph, and identify the independent and dependent quantities. Okay. So the first ordered pair, if we have cars washed, 1, and the total amount earned, 7, that's going to be represented by 1 comma 7. So in the graph, 1 comma 7, and then we have 2 cars washed, 14, 3 cars washed, 21, 4 cars washed, 28. So when we connect all of these together, it's going to ask us, okay, what do you notice about, analyze the graph? What do you notice about the graph? So if we connect all these together, it's a line. That's supposed to be a straight line. So the fact that it's linear is going to be important to know. And it's important to know if we washed 0 cars, we earn 0 money. So it does go through the origin. That's something else that's important to make note of, especially when we start talking about multiplicative versus additive relationships in graphs. That's going to be an important feature, so keep that in mind. And finally, the actual relationship is that it increases $7 each time. For each car that you wash, you get $7 more. So finally, even though it's kind of obvious at this point, what is the independent quantity? What's the dependent quantity? Well, if you wash more cars, you earn more money. So the which one is dependent? Is the amount of money that you earn dependent, or is it independent of the number of cars you wash? Answer that for me now, please. Okay, the fact that it's actually on the y-axis is a huge clue too. Y-axis is always the dependent variable. So y is the dependent variable. If you wash more cars, this is the independent value. You earn more money. So the amount of money you earn depends on the number of cars you wash. And the independent value is always the x-axis when you graph it. So something important that we need to remember about this lesson. Um, Please think about that. Go back and review your notes before you answer. If you answer I don't know, then I will zero out your points and you'll have to rewatch the video to earn them again. Just take a moment, look through the pages, and come up with one thing you think is really important to know from what we talked about and practiced in this notes video. Go ahead and answer that for me now. All right, thank you for your thoughtful answer, and I would please come to the Math Live class. I'll encourage you to do that. We're going to do some more examples together. Take care.